So after your refresher of Pythagoras, we'll proceed with the first concept of this unit, which is the tangent ratio. And you'll find it on page 70 is where it begins. And for the tangent ratio, this lesson focuses only on how to find unknown angles. It doesn't focus at all on how to find unknown sides. So let's take some notes on the tangent ratio. Say I've got an angle here. Triangle here with side lengths 3. No, make this a 4 and this a 3. And I can use the ratio to find any of the angles. Now, the tangent ratio. And the tangent ratio is defined as, let's say this is the angle I'm trying to find. We'll call this angle A because it's opposite of side A, opposite of the short side. So we'll call it angle A. And there is, if you're finding the tangent of any angle, it is equal to length of the side opposite. What's opposite of this angle? It's this side here, all the way across, the opposite. Length of the side opposite divided by length of side adjacent. What does adjacent mean? It means right beside. Now what is right beside this angle? This one here. Our two known sides. One is all the way across on the other side, and one is right beside our known side. Okay, length of side opposite divide by length of side adjacent. That's your basic concept. And once you know what the basic concept is, you simply go ahead and apply it and learn it, how it works, fairly quickly. Now, it requires the use of a scientific calculator. The ones that we use all the time have this particular function. So I'm going to write this down, then I'll show you how to do it. The TI-83 calculators must be set to degree, because you're trying to find an angle, right? Angles are measured in degrees, must be set to degree. But even when we get to finding unknown sides, you'll need to have your calculator set in degrees. So let's review how to do that. Normally, a calculator is set in radians, which is the normal numbers. We want to set it in degree. We go to mode, which is beside your orange second key. Press mode. And then, very simple, go down. You see the third line. Go down to the third line. You've got it set on radian. Move it over to degree. Press enter. Your calculator must be in degree or it will not give you the correct answers for trigonometry. Trigonometry needs the degree setting. It's different from almost every other kind of math. So how do we do this math then? Got our calculator set up. We know about our formula. We're going to now solve this triangle. We're going to find the measure of angle A using the method. So, tangent is equal to length of side opposite, right? Look here, length of side opposite. Now what is opposite of the angle we're trying to find? It's 3. Second part of the formula, length of side adjacent. What is beside the angle we're trying to find? 4. I forgot one tiny detail. No, I didn't. It's good. We're going to get to that. I was running ahead of myself. So, tangent 3 divided by 4. Okay? Go to your calculator and you'll find the 3 keys here. Sin, cos, tan. We're using tan for tangent. These two will come into play later in the unit. For today we're using tan for tangent. Tan, tangent, 3 divide by 4. We get our answer as a decimal. How do we convert it out of a decimal? We're going to get to that. First, we're going to write this down. Tangent, 3 divided by 4, and we're going to write 0.01309. 0.01309. I'm just rounding it off to 5 decimal places. You can go as long as you want. It doesn't matter. Now, how the heck is this an angle measurement? I thought we were finding an angle measurement. The answer is tan inverse. Tan -1. And then I punch this in. Tan inverse 0.01309 equals. So let's show you how to do this part. Clear? I'm going to need the second key, the orange key. And then I press tangent again. Notice my tangent has a little negative sign next to it. That means tan inverse. And now I punch in the decimal that I got from dividing earlier. 0.01309 bracket. Voila! That angle there is a 75-degree angle. 74.9 or 75 degrees. 0.7499. .75 degrees. So there's your basic idea of the tangent ratio used to find unknown angles. Let's do another example of this. I'm going to grab this example from page 72. Don't necessarily have to go there. I'm going to sketch it right here. Sides of 12 and 6. We know that this angle is a 90. We want to find this one and this one. So, let's start with the small guy on top. Okay, so you're now ready for a shortcut, I would think. Okay, so here we go. We're going to find this angle on top. We'll call this angle A and this angle B. So we're trying to find this one, right? So tan inverse, we're going to use tan inverse angle A is equal to, what's opposite of angle A? 6. What's adjacent to angle A? 12. Second, tan, 6 divided by 12, 26.6 degrees. So I did this tan inverse. Instead of doing the decimal and then the inverse, I simply did tan inverse. So second tan, 6 divided by 12. Show you. You can skip a step with these TI-83 calculators. If If you're finding an angle, tan inverse 6 divided by 12, 26.6. Let's do the next, the other angle here. Meakin do 180, use 180, subtract 26.6. Subtract this one down here. 180, subtract 26.6, subtract 90. Could do it that way, but I want us to get more tangent practice. Tan inverse, finding angle B. Looking at this, the opposite is 12, the adjacent side is 6. Second, tan inverse, 12 divided by 6, 63.4. Let's say you want proof that this worked, right? 26.6, add 63.4, add 90. I'm adding up three angles of this triangle based on what I found. 26.6, 63.4, add 90, 180 degrees. Checking my math here, right? Proof that these two are indeed the correct answers. Okay, let's have a look over on, there's a nice example on page 73 that we're going to do. Let's have a look. This one here, check your understanding. Clyde River on Baffin Island, Nunavut, has a latitude of approximately 70 degrees. The diagram shows the side view of some solar panels. Determine whether this design for solar panels is the best for Clyde River. Justify your answer. So you want your angle of, that's it, your angle of inclination of your solar panel, which is down here on the bottom, you want that to be at least 70 degrees. Okay, so we're going to solve for it and find out if it is. Again, I'm going to do a sketch. So we're dealing again with the example on page 73. This is 70, this is 208, and you have a solar panel going up here at an angle. So we're only asked to find one angle here, and that's this one. The angle of, calling it the angle of inclination. How much is your solar panel tilted? So we're going to call this angle I, because it's the angle of inclination. How brilliant is that? Tan inverse I, this angle. Opposite is 208, adjacent is 70, equals 208 over 70. This time I'll show you my calculator screen one more time to make sure that we've got this computed. Hit the second key, hit tangent. I now have tan inverse 208 divided by 70. 71.4 degrees, it says. So this angle, good to go. It's at least 70, it's 71.4, so the design would appear to be good. Or so they say. Let's do one more example, then I'll give you some homework on this concept. Managing to keep this recording to a reasonable length so far. Page 74. A 10-foot ladder leans against the side building with its base 4 feet from the wall. What angle to the nearest degree does the ladder make with the ground? So they got a nice diagram here, and we want this angle is 4 fuß für die Wand und der Lader ist 10 fuß. We want the angle here that it makes with the ground. Ten, 4, I've been double do a hope. So want the angle that it makes with the ground, and let's just call it G then, right? Tan inverse G equals so who can see a problem here? We want to find this angle. But in order to do that, we need to know what the side opposite is, don't we? We have the two sides that are beside it. We don't have an opposite. We need an opposite to make our tangent ratio work. Opposite over adjacent. So, we're not going to start with tangent. We're going to start with our old favorite, Pythagoras. A squared plus b squared equals c squared. We're going to find this side here. So, a squared, 4 squared. B squared, we don't know, 10 squared. 4 squared, 16. B squared, 10 squared, 100. And 100 minus 16 is 84. And we're going to do the square root of 84. 9.2 feet. We now have 9.2 to work with. Now we can go ahead with our tangent, as we were going to do to begin with. Tangent inverse G equals, here's the angle we're trying to find. 9.2 is opposite. 4 is right beside. The long side is never adjacent, by the way. For tangent, use man de två sidorna. You use side A and side B. You don't use the longest side. It's just the rules of tangent. When we get to the other ratios, you'll be using the long side, but not for tangent. And today we're focusing only on tangent. So we can simply say that angle G is equal to, and let me show you one more time how to do tan inverse second. Tan 9.2 divided by 4. 66.5. Homework. Page 75, number 5 and number 8, page 76, number 10 and number 12. So let's go over those. Page 75, number 5. 5 different triangles where you're given 2 sides and asked to find a given angle. The angle that's marked off, right? So here, I would simply do tan inverse 3 divided by 6. See? 2 sides, you're finding a given angle. Number 8. Determine the measure of each indicated angle. You're finding 2 sides. Again, you have 2 sides and a given angle. So this is basically similar to question 5, I guess, except for your sides are including decimals. So very easy on page 75, I hope. 76. Page 76, number 10. Determine the angle of inclination of each line. That's these guys. Down at the bottom, right? Inclination, wie richtig is sloped. Here, here, here. Right? So you've got your two sides. Let's have a look at this one, for instance. You're trying to find this angle. Opposite. Tan inverse, 3.4, divide by 9.2. See that? You do have an opposite and an adjacent side for each of these. You won't need Pythagoras, simply. The angle, opposite, over adjacent. Okay? And your last exercise for today is going to be number 12. Approximate latitudes for several cities in western and northern Canada are shown. So we're given a whole bunch of latitudes here. Calgary, Fort McMurray, so on and so forth, Whitehorse, Saskatoon, Inuvik, Kamloops. So the question is, for which locations might the following roof design be within 1 degree of the recommended angle for solar panels? Your solar panels are based on your angle of latitude. Okay, so you're going to find the angle of inclination here, down here at the bottom, right? So here's your angle, opposite over adjacent, tan inverse 5 divided by 2.8. So now you've got your number. Now, for which cities is that going to be within 1 degree, right? If it's 52, then it works for Calgary, but it doesn't work for Fort McMurray. It all depends what your answer is going to be. That's just hypothetical on my part, right? Okay, so those 4 exercises, page 75, 5 and 8, page 76, 10 and 12. Remember to do some Pythagoras refreshing from that previous worksheet. As you see, Pythagoras keeps on popping up. He doesn't go away. You're working with triangles, you're doing Pythagoras. And there's only going to be 4 school days this week, so that's going to be it. Just these 2 lessons. And your final review from the previous unit needs to be coming in. I believe I've only seen 1 so far.